Okay, so let's continue with our graphs. Last time we started graphing and we found the effects. I think we were on this slide. Hang on just a second. We're on this slide. We did this problem together and we found out the effects of that too. It made the graph, it made a vertical stretch, right? So let's continue now. With this graph, it's slightly different now. And there's a couple new things on this graph. And so what we're interested in now is figuring out, well, let me see if my pen's going to work. Okay, what does this 3 cause? What's this 3 over here sitting by itself? Like, what is this C over here called? If you have a number.
Is it like a rise over run kind of thing?
Is it a rise or a run? Well, this might be something like that. But remember, we're doing parabolas now, so lines that we had, whoa, whoops.
Where's the point you're going to start at first?
What's that?
Where's the point that you're going to start at first? And then going on with it?
What did I do? I know, but I want my graph to still be, oh, hang on. Okay, so like when we did lines before, you had rise over run, okay? But, so you had slope before, you know. But parabolas don't really have a slope. I mean, not the same like lines. So hopefully that won't confuse you. But they do have these other characteristics. Like we saw last time, we had a 2 sitting right there. And we saw that the 2 makes it more steep, right? So let's take a look at this graph. And once again, for the first couple of graphs that you're going to do, maybe like the first 3, you're going to put the parent graph with it. Okay, this is what we call the parent one. And the parent one, you should start to know it's going to be right here, right here, right here. And then when x is equal to 2, we get y is equal to 4. So we're right there. And when x is equal to negative 2, we also get 4. Okay, so we were doing the parent graph last time. So the parent graph looks something like this. And try not to make it too pointy. Parabolas always have the curviness to them. They're rounded a little bit, and so I kind of do that kind of slow, but there's our parent graph. So let's say on the first 3 problems we're going to include the parent, okay? But then what we want to do is compare that parent graph with the current graph that we're dealing with. This is like some sort of offspring. I mean, all these parabolas look kind of like the parent, but this one's going to, certainly something else is going to happen to it. Okay, so if you take these values and you substitute them in for x, what do we get? Well, we'd have negative 1/2. And then we're going to put 4, negative 4, and we're going to square that number, and then we're going to add 3, right? Well, negative 4 squared, 16, right? So you have 16. Now, remember, a negative 4 times a negative 4, that, oh, you can't see that? That anyhow, it's going to make it a positive 4. Negative times negative is a positive. Maybe I should switch. Okay, so we get positive 16 here, right? But then what do we need to do? We need to multiply it by that half. So, and that half is negative, so a negative half times a positive 16 gives me negative 8. Okay, we're good with that? Okay, can everyone see that okay? Alright, then we just cycle through all these other numbers. We put in the negative 2. Oh, goodness, I almost had it right. Who didn't? Noel caught that. Okay, so hold up just a second. We were supposed to add 3 after that, right? So we had negative 8, and then we add 3 to that. And so now what do we get? Thanks, Noel, for catching it. Negative 5, you see? Alright, so again, once again, we cycle through the rest of the numbers, though. I'm going to take this negative 2 and plug it in there now, right? And I'm not sure. On the side, you could do these calculations, you know, just somewhere on your paper. Negative 1/2 times negative 2 and then you square that, and then this time let's add the 3 on there. So negative 2 squared though is 4, so that's going to be 4, and then you multiply it by this negative 1/2 out in front, right? Negative 1/2. Well, half of 4 is 2, so this is going to be negative 2, but then we add 3, right? Okay, so then I think we end up with positive 1 right here. Okay, does this sort of make sense? Okay, so 0 is pretty easy to plug in, right? 0 squared is 0, 0 times 1/2 is 0, and then you add this 3, so that one's going to be 3. And now let me just give you a hint. Well, it's when we plug in the 2, we're going to get the same value we got before, except we're going to add 3 now. So let's see what happens when you plug in 2. You see, if you plug in the positive 2, the positive 2 squared is going to be 4, just like before. Multiply it by 1/2, you get negative 2. Then you're going to add 3. So you get the same number here again, right? And guess what this one's going to be? Oh, negative 5, right? That's going to be the same thing, right? Because if you put in this 4, it's just like the first one we did, like right there, except for it's positive 4. Well, positive 4 squared is 16 also, and then negative 1/2 of 16 is negative 8. Then you add 3 to it, so you get negative 5 again. So we have plenty of points here to plot. So let's plot our new curve, and then let's compare it to the parent. Okay, I'm going to use this cool pink color. So at negative 4, 1, 2, 3, 4. We're at negative 4. The graph is at negative 5. So, or the y value. 1, 2, 3, 4, 5. So here's one of our points. And at negative 2, when we're at negative 2, we're at positive 1. And then when we're at 0, we're at positive 3. Okay? And then at positive 2, we're back to 1 again. And then at positive 4, we're at negative 5. 1, 2, 3, 4, 5. And see, so you'll notice a couple things different about this parabola versus the parent one. Well, I tried to draw it, but there it is. It's kind of going like that now. Okay, so when we compare my red graph to the green graph, what's the first thing you notice about the graph? Anyone see anything different? How would you compare it? It flipped, for one thing. And my friends, think about, what do you think caused the flip in this problem? The negative. The negative caused the flip. Okay, so I agree. That's a good observation. The negative right here caused the graph to flip. Okay, this causes a flip. Okay, and that's pretty easy to recognize. I mean, if the number out in front is negative, the parabola opens down. If the number out in front of the x squared term is positive, the parabola opens up. That observation is correct. What did you notice about this vertex right here? It's at 0, 0. This one's up here at 0, 3. What do you think caused that? Should be fairly obvious, right? The plus 3 right here, you see? Okay, so this number that we have sitting out here, what does it do to the graph? That number simply shifts the vertex, or shifts the whole graph actually, 3 units up. So if we summarize that here, let's take a look here. This C here caused a shift 1, 2, 3 units up. So this caused a positive shift. So that caused the graph to go up 3 units from here to here. The negative then flipped the graph so that it's going down instead. Okay. And did you notice something here? Does this graph look steeper or more shallow than the other graph? It's more shallow, right? You see, the first graph that we did y is equal to 2x squared. And the graph that we're now looking at is basically 1/2 x squared. You see? So here's how it works. If this number is bigger than 1, then it causes a stretch. If it's less than 1, it causes like a compression. Does this make sense? So you'll notice, like, if this were like 1/4, for example, then what happens is the graph becomes more shallow, or it becomes what we call compressed. It becomes more and more flat. And if you had like y is equal to 6x squared, we saw what happened to that one. That's the graph we did last week. That one shot up a lot straighter, right? It starts to shoot up quick, right? So what we want to do before we go a whole lot further is we want to start summarizing some of the things that we've learned. Does that make sense? So let's go here because it's gotten pretty messy. So these are some of the properties, and there's a new one on here that you don't know about. We're going to get to it in just a second. So some of the properties we just found out is this one. Okay, the graph opens up if a is bigger than 0. It opens down if it's less than 0. Okay, in other words, if it's negative. We talked about this, narrower and wider. Okay, so if this a value, and it's talking about the a value right here, and sometimes we take the absolute value of a. If the absolute value of a is bigger than 1, then the graph gets narrower. And we call that a vertical stretch. A vertical stretch. Okay? And this one we call a compression, like a vertical compression. It's like you're flattening it. And it's like you've taken your hand and you're flattening the curve out. So it's a vertical like compression. Vertical compression. Alright, so you don't have to write these down because we're not taking Cornell notes, but anyhow, those are some things that we learned. Now, here's another thing. This is a pretty cool trick that someone came up with. Lots of times we want to find out where that maximum point or that minimum point is. It turns out you can find it quickly. You can find it by using this idea here. Let me put one more note here. The vertex. Okay, so the vertex, that's this lowest point right here, you see? That's often a point where the graph turns around and starts going back the other direction. Same thing going in this one. It goes up for a while and then it turns around at that vertex and starts going back down the other way. You see? So that vertex is often, we call that a maximum and a minimum. In this case, it's a minimum of that curve. The curve will never be below that point. In this case, it will never be above that point. Well, we can find out the x-coordinate. The x-coordinate is negative b over 2a. And that's going to help us a great deal as far as graphing, because that x-coordinate is also where this axis of symmetry has to be. The axis of symmetry is this red line going right here. It always passes through the vertex, like that. Okay, so what I want to do is show you how these ideas here help us graph faster, a little bit more quickly. You start using these facts, okay? So let me demonstrate this, and then what we'll do after I do these next examples, we'll work on our study guide for a little bit, okay? So I don't want to go too much longer. Okay, so let's look here. Oh, one more thing. You can find the intercept easily. This is called the y-intercept, and that occurs when x is equal to 0. So, okay, let's demonstrate these ideas on this next graph. Alright. So, usually what I would say, the first thing I want to do is find the vertex. Okay, so find the vertex. Okay, so according to what that last, oh, I'm doing this in black, can't see that. Okay, so find the vertex. Vertex, okay. That's what we want to do first. Now, the vertex is going to be the spot where it turns around. I mean, it's either going to do that or it's going to do this. By the way, real quick, can I determine which way it opens? Is this going to open upwards or downwards? That number there is positive or negative? It's positive. So this parabola does open upward. Okay, so that means it has a minimum. Well, this vertex then is going to be the minimum point. Okay, so how do I find that out? Well, I use a little trick that someone discovered a long time ago. Actually, you can show this in calculus, but we'll save that for another day. The x coordinate that's at the minimum, okay, we have an x and y coordinate, that's going to be our vertex. The x coordinate is real easy. It's equal to negative b over 2a. Oh, so what numbers do we use? Well, see, anytime you have the quadratic, there's your a, b, and c. So you just have to find the number that's sitting in front of the x squared term. You see, there's your x squared term. There's your x term. You see, according to this equation then, this one is my a, this is my b, and this is my c. Okay? There's your a, b, and c. So, what you want to do is put this b value in right here. Okay? Take your a value and shove it in right there. You see? Now be careful, there's a negative here and there's a negative here. Some people make a mistake and they get confused. Okay, so let me show you what we get here. We get x is equal to negative, and then you have a negative 8, and then you have 2 divided by whatever a is. Well, a is 2. Okay, you see? And now we've found the x coordinate. Well, we have to simplify this because a negative times a negative is a positive, of course. So that's positive 4. And then down here we have 2 times 2. Well, hold up here. That's positive 8. Positive 8, right? And then 2 times 2 is 4. Well, 8 divided by 4, of course, is 2. Alright, so the vertex, I know it has the coordinate 2. And now what I need to do is find out the y coordinate. Now the y coordinate is pretty easy because the way I find the y coordinate is I take this 2 and I shove it in right back up here for x, and I put it in right here for x, and because see that tells me what y is equal to, it's equal to this. So if I want to find the y coordinate, I'm just going to go up there and plug it in. Now this takes a little while in practice, but you'll notice you'll get a lot faster as you get better at this. So in this case we get y is equal to 2 times 2 squared minus 8 times 2 plus 6. Now if you're not very good at this, I would use your calculator, but you can't see the color. Now you tell me you can't see the color. Okay, so I'll redo it. Whoops, I thought I did yellow. You're supposed to tell me a moment ago before I wrote it all down. Okay, so 2 times 2 squared minus 8 times 2 plus 6. Now you can see it, right? Okay. Well, 2 times 2, this is 2 squared, right? So that's 4 times 2 is 8. And this is 8 times 2, which is 16. And then we add 6, right? So 8 minus 16 is negative 8. And then you add 6 to that. It gives you what? Negative 2? What you just found out then is this y coordinate is at negative 2. Okay? So what we have, according to our graph so far, is when we're at x equals 2, we have negative 2. That's the vertex. Now, one thing we just learned from the previous slide is that the axis of symmetry passes through the vertex. See, so there, this is where we have like a mirror image. Like if you have a point over here, there's a second point over here. Does that make sense? Okay, so what that means now is that I only have to graph a couple more points and I'll have my graph. Let me show you how to be smart about this. I'm going to use an eraser now. Now that I've gone through the trouble to find out where the vertex and the axis of symmetry is, let me show you how you can find a couple points real fast. Okay, so let's pick black here, I think would be good. I want to pick a point that's nearby this axis of symmetry. How about x equal to 0? 0 is pretty close. It's only 2 units from the axis of symmetry. I know that when I get this point plotted that there will be a second point on this side, the same distance. So let's take a look. If I plug in x equal to 0, can you guys? Oh, that's a little hard to see. I'll plug in x equal to 0. Okay, so I'm going to plug in x equal to 0 here and right there. You see? So I get y is equal to what? I get 2 times 0 squared minus 8 times 0 plus 6. Isn't that one easy? You get y equals 6. Okay? That one's real quick. Okay? So when x is equal to 0, I'm up here at 6. Okay? If you see this here, this is an axis of symmetry right here. It always passes through that vertex. So you know what I know? I know there has to be a second point right here. I don't have to check. There's an axis of symmetry. So to graph my parabola now, I'm just going to draw a line, make it curvy. From here, go down to the vertex. That's my lowest point. Bam. And turn around and come right back up this way and pass. Well, kind of make it look more cool than that. And see, there you have it. So what we want to do then are steps on how to graph these. Okay, number one, we want to find the vertex. Okay, to find the vertex, remember what we do. We find the x-coordinate first. It's equal to, well, you guys can't see that. It's equal to, the x-coordinate is equal to negative b over 2a. Okay? You guys see that? What? Hang on, why isn't it? You guys? What happened to my... Hang on. My computer froze for a second. Is it still going? Yeah. Okay, it's going now? Okay, so negative b over 2a. I don't know, modern technology, sometimes they have glitches.
Is it still recording?
Yeah, it's still recording. So, after you find that, that's how we ended up getting this 2. Okay? Then you take that 2 and you substitute back in up here and you find the y-coordinate. That's how we got the y-coordinate. Well, that's how we got the negative 2. Anyhow, let's do another problem because I'm sure it takes a while to get these ideas down, okay? So let me demonstrate these ideas one more time. Alright, you guys ready? Let me use a color, better color. How about this orange? Kind of brownish orange. Okay, so my first step I want to do is find the vertex. Okay? You guys okay with that? Vertex. Remember, that's the place where the curve either turns around, either going back up or back down. You can't see it? Alright, thanks for letting me know. How about this hideous blue? Alright, that you guys can see? Alright. So we want to find the vertex. Alright. Alright. So, how did we say to do it? X is equal to negative b over 2a. Alright? Well, where's your a, b, and c? The a, b, and c is sitting right here. There's a 1 sitting right out in here. We can always add in a 1, right? Okay. So, that's the a. Okay? This negative 2 right here is your B. And this one is your C. Okay? So according to this equation then, I'm going to have negative 2 over 2 times 1. And I think I can figure that. Negative times negative is a positive, so that's a positive 2. That's a positive 2 down there. So the x-coordinate is 1. So as far as the vertex goes, I found one of the coordinates. It's equal to 1. Now what I need to do is find out this one. How do I find the y-coordinate? Well, I take this one here, okay, and I put it right in here, and I find out the y-coordinate. You see? Does this sort of make sense? So now what I do is I say y is equal to 1 times 1 squared minus 2 times 1 minus 1. Okay? And let's see, can we do this in our head? 1 squared is 1 times 1, so that's 1. 2 times 1 is negative 2, and then minus 1. So that's minus 3, 1 minus 3, I think that's minus 2, right? So what I found out is that the y-coordinate is actually minus 2. And so now I can plot this vertex. By the way, does this open up or down? You see, that's a positive number, right? That's positive. So this thing's going to open up again. Okay, so I'm using that little fact now. So when I'm at positive 1, I'm at negative 2. There's my vertex right here. All right. And now, if I'm clever, I can go ahead and draw in this axis of symmetry. I know there has to be an axis of symmetry right here. Okay, so I like to draw that in, you know. Can I put the graph up? Oh, let me try here. Is that better? And then again, notice there's that's where the vertex is. So really all I need to do is put in one more point and then use the mirror image idea, and I'll have my graph. So here's the thing. People always ask, well, what? Oh, you're kidding. Okay, don't worry. I had it right here, right? Hang on. Is that negative 1? Okay, there was my vertex, right? And I had my axis of symmetry. I'll try to draw it again. It was going through right here, right? Okay, so people always ask, well, what x value should you use? Okay, what x value should I use now? Well, here's how you decide. You pick a point that's nearby the axis of symmetry, because if I pick a point way over here, like x equal to 7, guess what happens? This parabola opens up, right? And way up at 7, it's going to be way off the graph. You see? So don't pick x equals 7. Pick something that's closer. Like, how about x equal to 3? That's pretty close. That's not too far away. So what I would do is I would pick x equals to 3. That might be a good choice. Okay, so again, we have a vertex point right there. Put that back in as yellow. So what I want to do now is, how about x equal to 3? If I use x equals 3, I'll put that in right here. I'll put it in right here. So that gives me y is equal to 3 squared minus 2 times 3 minus 1. Okay, so 3 squared is 9, minus 2 times 3 is 6, minus 1, right? So 9 minus 6 is 3, minus 1, that gives me 2. Okay, well, the point is, pardon the pun, when x is equal to 3, my y-coordinate is 2. Now, where's another point? Oh, be careful. Negative 3, the axis of symmetry is here. Now see, I went over 2 units this way, right? So if we go over 2 units this way, it takes us to negative 1 and then up 2, right? So there you go. You see how that works? You have to base it off the axis of symmetry. Well, now I have this cool little curve that kind of goes through here and turns around and goes through there. Alright, so there's my parabola. Hopefully it looks nice and beautiful to you. Any questions? Alright, so now what you need to do for your assignment is about 600 of these, and then you'll be good at it also. Alright, so here's where I want to stop for today, and I want you to go ahead, I want you to go to your study guide, and I want you to work on some graphs, just like I did. And how about what we do is we do numbers 2, 3, 4. Well, let's just try to finish up the study guide. You can have the remaining 15 minutes in class, and whatever you don't finish in class, I want you to go ahead and do for homework. So, when... No, there's only the 6 Oh, we'll get to the back tomorrow. That's where we're going to start tomorrow, okay? So, we'll save the back for tomorrow, and that will be in part 3, okay? So part 2 is done. And now what I'll do is I'll go ahead and stop this, and we'll work on this for a while in class.